Assalamualaikum and hi everyone. Today we want to present our group project for STA 150 about probability analysis of pen drop distance from the target point. My name is Putra Haziq Norsham bin Shamsul Kamal and my student ID is 2024693758. Without wasting time, let's begin. The objectives of this experiment is, first we want to study the probability distribution of pen drop distance from a target point. Second, we want to compare experimental probability with theoretical probability. And lastly, we want to analyze factors affecting the accuracy of pen drops. For the problem statement, we want to know how far does the pen deviate from the target, and is the distance distribution random or pattern. And for the methodology, we need material and equipment such as standard pen, measuring tape about 2 meter, ruler about 30 centimeter, masking tape and flat floor surface. For the procedure, first we have to create a target marker on the floor. Second, we have to hold pen vertically at 1 meter height. 3. Release pen without pushing force. 4. Measuring straight line distance from target in centimeter. 5. Repeat this step until 25 trials of the data obtained. And the control of this experiment is, first, same pen height and percent. Second, consistent environment like no wine and same surface.
Assalamualaikum, my name is Nuhaika bin Yamsari. My student ID is 2024421786. Here a sample of our 25 trial. Distance range from 1.2 cm to 14.5 cm, but mostly value casted between 3 to 5 cm. Trial 7 was an outlier at 14.5 cm, possible to do an uneven bounce. When we group the data, we found that 44% of drop land in the 3.1 to 5.0 cm range. This immediately suggests that the distance were random. They cluster in this medium range. Our calculation showed average distance is 5.22 cm, standard deviation 3.17 cm. This means while the average miss was about 5 cm, the results were quite inconsistent, sometimes very close, sometimes very far. We found that if the pen missed by at least 3 cm, there was a 69.9% chance it actually missed by at least 4%. The 3.5 to 5 cm range was most common, occurring 11 times out of the 25.
Assalamualaikum, my name is Amir Shazib bin Kamsol and my student ID number is 2024279008. Now for this slide, we compared our results with the uniform distribution model. The theoretical model predicted only 50% probability for the 3 to 5 cm range, but we observed 48%, which is much higher. Next slide. Why the difference? The differences come from real world factors like pen aerodynamics and air resistance, slight variation in release, measurement errors, and surface imperfections. The uniform model assumes perfect randomness, but physical systems have patterns. Next slide, we're gonna answer some questions for part 1. For this, we work with the PDF functions equal k times x from 0 to 5, we found that k is equal to 2 over 25 and CDF function is equal to x squared over 25. Next time, for part 2, we calculated that the expected value is 3.33 centimeters and variance 1.389. These theoretical values are lower than our experimental results, confirming that real data has more spread.
Assalamualaikum and hi. My name is Muhammad Hazril Nasrallah Biazalia and my student ID is 2024208146. So, I will explain about the moment generating function. We also derive the moment generating function or MGF which fully characterize this probability distribution. The MGF is given by using integration by parts. We arrive at the final expression. The MGF is useful because it can be used to derive all moments of the distribution, such as the mean and the variance. Okay, so for our conclusion, we found that the pairs most often landed between 3.1 and 5 cm. The results had high variation, so the distance were not consistent. Our experiment also did not fully match the theory because real life factors affect how the pen falls. The main message is that real experiments are different from theory, and doing more trials will give results that are more accurate. For improvements, we suggest using a larger sample size and making the release method more consistent.